Now we will find the potential difference related to a source charge. What do I mean by that? Now I have a source charge here Q, and with respect to this I am moving another charge small q from a position to a different position. So let's say that is from B to A. So we have only one definition for potential difference. What is that? Potential difference in between A and B, VAB, is equal to VA minus VB is equal to work done in bringing a charge from B to A divided by the value of the charge. Okay, now here there is a problem. Why? In the previous case, we have taken an example where electric field was uniform, but here the electric field is not uniform. How come we know that? Because we have already learned the value of electric field of a source charge. What is that? Electric field is equal to 1 by 4 pi epsilon 0 q divided by r square, which means when value of R increases, electric field decreases. That weakens. Clear? Okay. Now here at this position we know that it is at RA distance, and here it is at RB distance. So it is very clear that as the distance is small here, the electric field is stronger here, it is weaker here. So it is at higher electric field and it is at lower electric field. So here in this case, we can't simply multiply electric field with displacement. See, we can find the value of work done as force into displacement. But when the force is varying with respect to position, then we have to integrate. Clear? We can't simply multiply. So this is F dot dr, dot product basically. So here in this case, we have to integrate. Why? Because the work done for a small distance in between these 2 points will not be the same when we are moving the same amount of distance in between these 2 points. Why? The electric field or the forces are varying. Here we have to do higher energy, higher work. Why? Because here it is at stronger repulsive force. See, here it is very close to this charge. So to move 1 centimeter here, we have to apply more, we have to do more amount of work. But to do the same here, we have to do lesser amount of work because it is very far away. We can easily have 1 centimeter displacement here, but that is not very possible in between these 2 points because electric fields are not the same. Clear? Now, anyway, come back to this. Now, how will I get the value of work done? Here in this case, work done will be equal to the integral of force into, here it will be dot product F dot dr. All the time work done will be dot product of force and displacement. So potential VAB is equal to work done divided by charge. So work done is nothing but integral of F dot dr. Why we have taken an integral here? Because its force is not constant. If at all, if it is constant, I can simply take it as F into dr. If it is not constant, we have to integrate. Now, what is F? F is nothing but force, here in this case, that is QE. And we know one thing, we are taking the displacement in leftward direction, but the force is rightwards, which means the angle in between the displacement and the force are 180 degrees. So I can simplify this as F is nothing but QE dot dr divided by Q. Now this E is nothing but electric field by the charge Q. Okay. Now anyway, Q and Q will cancel. So this is basically integration. Now I will have E dot dr. Clear? Now what is the value of E dot dr? Q have cancelled, and electric field is basically due to the source charge, that is the bigger Q. And what is the value? 1 by 4 pi epsilon 0 into Q by R square. So at a position, let's say this is at a distance of r, and we are going to have a small displacement of dr here. So this will be 1 by 4 pi epsilon 0 q by r square dot dr. So this will be dr cos theta. So a dot b is nothing but ab cos theta. Now what is cos theta here? Dr and he are 180 degree apart. So cos theta will become cos 180, which is minus 1. Now in between, which are the point we are integrating? In between b and a. So from b to a we are going to do the integration. Clear? Now what is this? I am going to take this here. So what is this? Integral of b to a 1 by 4 pi epsilon 0 q by r square into dr. The minus sign I will take outside. This is equal to VAB. That is the potential difference. Okay. Now all these things are constant. Q and 1 by 4 pi epsilon 0. I am taking it outside. Q by 4 pi epsilon 0 integral from b to a 1 by r square dr. Now 1 by r square is nothing but q by 4 pi epsilon 0 into 1 by r square is r power minus 2 integral b to a dr. What is integral of x power n? Integral x power is n is x power n plus 1 divided by n plus 1. Just raise the power by 1 and divide it with the same value. So q by 4 pi epsilon 0. Raise the power by 1. So r power minus 2 plus 1. Minus 2 plus 1, that will be minus 1. So r power minus 1 divided by minus 1 from b to a. Clear? I have a minus outside. See, this cos 180 minus I have to take outside. Okay. Now this minus and this minus I will multiply and that will vanish. So what is this? 1 by 4 pi epsilon 0 into q. R power minus 1 is nothing but 1 by r from in between b to a. How can I simplify this further? Upper limit, substitute the upper value and lower value. So this will become 1 by 4 pi epsilon 0. So this is q. So q into 1 by 4 pi epsilon 0 is nothing but q by 4 pi epsilon 0. Put upper limit, then subtract with lower limit. So what is upper limit? 1 by ra minus 1 by rb. So this is the potential difference due to a source charge. Okay, so this is the source charge. With respect to the source charge, we are moving a different charge of q in between b to a. But anyway, potential difference is independent on this test charge. See, can you see anywhere a value of q, small q here? No, right? Because this q, has a role in determining the total work done. But after that, we are dividing it with q. So this q will cancel, and basically potential difference is for unit charge. So for 1 coulomb to move from b to a with respect to a source charge of q, this much amount of work need to be done for 1 coulomb. Okay, what is the value? Q by 4 pi epsilon 0 into 1 by Ra minus 1 by Rb. Thank you.